Have you ever wondered what secrets lie within our solar system? We humans have gazed up at the stars for millennia, wondering if we were alone in the vast cosmic ocean. Our solar system is teeming with planets, moons, asteroids, comets, and a dazzling array of celestial phenomena. Our journey begins at the heart of our solar system, the Sun. This isn't just any star. It's a G-type main sequence star, a cosmic furnace that has been burning for billions of years. The Sun's gravity is what holds everything together, keeping the planets locked in their orbits. And it's the Sun's energy, radiating outwards as light and heat, that makes life possible on Earth. Without the Sun, our planet would be a frozen, lifeless rock. But the Sun isn't just a passive provider. It's a dynamic and active star. Sunspots, solar flares, coronal mass ejections, these are just some of the events that remind us of the immense power the Sun holds. These phenomena are not just visually stunning. They can have a real impact on Earth, affecting our satellites, communication systems, and even our power grids. Our next stop takes us to the closest planet to the Sun, Mercury, a world of extremes. The surface temperature on Mercury can reach a scorching 800 degrees Fahrenheit, hot enough to melt lead. But Mercury's proximity to the Sun also makes its year incredibly short. It only takes 88 Earth days for Mercury to complete one orbit around the Sun. Recent missions to this enigmatic planet have revealed evidence of water ice hidden deep inside craters at its poles, places where the Sun's rays never reach. This discovery has challenged our assumptions about the inner solar system and raised intriguing questions about the potential for finding water, and perhaps even life, in the most unexpected places. As we continue our journey, we arrive at Venus, a planet often described as Earth's twin. Venus is almost the same size as Earth, and it has a similar composition. But that's where the resemblance ends. Venus is shrouded in a thick, toxic atmosphere composed primarily of carbon dioxide. This dense atmosphere traps heat, creating a runaway greenhouse effect that has turned Venus into the hottest planet in our solar system. The surface temperature on Venus hovers around a blistering 900 degrees Fahrenheit, hot enough to melt lead and turn the surface into a desolate volcanic wasteland. Scientists believe that billions of years ago, Venus may have had oceans of liquid water, just like Earth. Studying Venus is not just an academic exercise, it's a matter of understanding the delicate balance of factors that can make a planet habitable or utterly inhospitable. From the inferno of Venus, we return home to Earth, our pale blue dot, a sanctuary of life in the vastness of space. From a distance, Earth appears as a swirl of blue and white, with hints of green and brown peeking through. Earth is unique in our solar system, and perhaps in the entire universe as far as we know. It's the only planet we know of that harbors life, and it does so in astonishing diversity. From the smallest microorganisms to the largest whales, life on Earth is a testament to the power of evolution, and the intricate web of connections that bind all living things together. Our atmosphere, with its protective ozone layer, shields us from the Sun's harmful radiation. And the presence of liquid water, a key ingredient for life as we know it, is a testament to Earth's ideal distance from the Sun. Our cosmic journey continues to Mars, the Red Planet, a world that has captivated the human imagination for centuries. Even with the naked eye, we can see Mars as a reddish point of light in the night sky, fueling our dreams of one day setting foot on its surface. Mars is home to the tallest volcano in the solar system, Olympus Mons, a behemoth that dwarfs Mount Everest here on Earth. It also boasts Valles Marineris, a canyon system so grand that it makes the Grand Canyon look like a mere crack in the ground. Today, Mars is a cold, dry desert, but we've discovered tantalizing evidence that liquid water may still exist beneath its surface. And where there's water, there could be life. The search for life on Mars, even if it's just microbial life, has become one of the most compelling quests in modern science. Our next destination takes us to the outer solar system, where we encounter Jupiter, the undisputed king of planets. Jupiter is a giant, over 11 times the diameter of Earth and over 300 times more massive. But Jupiter's most striking feature is undoubtedly the Great Red Spot, a massive storm that has been raging for over 300 years. This storm is so large that you could fit 3 Earths inside it. Imagine winds whipping around at hundreds of miles per hour, lightning storms that dwarf anything we see on Earth, and an atmosphere composed primarily of hydrogen and helium, the same elements that make up the Sun. Jupiter is more than just a planet, it's a mini solar system in its own right. It has over 79 known moons, some of which, like Europa and Ganymede, are thought to harbor vast oceans of liquid water beneath their icy surfaces, making them prime candidates in the search for life beyond Earth. As we venture deeper into the outer solar system, we arrive at Saturn, a planet that needs no introduction. Even through a simple telescope, Saturn's rings are a sight to behold, a celestial ballet of ice and rock that has captivated astronomers for centuries. These rings aren't solid structures, they're made up of countless particles ranging in size from grains of sand to houses, all orbiting Saturn in a delicate gravitational dance. The origin of Saturn's rings is still a mystery, but they're thought to be remnants of a shattered moon, or perhaps material left over from the formation of the solar system itself. Saturn also has a fascinating collection of moons, including Titan, the only moon in our solar system known to have a dense atmosphere, and Enceladus, which spews geysers of water vapor from its south polar region, hinting at a subsurface ocean that could potentially harbor life. Our cosmic journey takes us next to Uranus, the ice giant that challenges our notions of what a planet should look like. Unlike most planets, which spin on an axis roughly perpendicular to their orbital plane, Uranus is tilted on its side, with an axial tilt of almost 98 degrees. This unusual tilt gives Uranus extreme seasons. For about a quarter of its orbit, one pole of Uranus points directly at the Sun, while the other pole is shrouded in darkness. Uranus is also unique for its faint ring system, discovered in 1977, and its collection of moons, named after characters from the works of William Shakespeare and Alexander Pope. One of these moons, Miranda, has a surface unlike any other in the solar system, with canyons, cliffs, and a jumbled mix of terrains that suggest a violent and chaotic past. Our final destination in this cosmic adventure takes us to Neptune, the 8th and farthest known planet from the Sun. Neptune is a world of deep blue hues, shrouded in a thick atmosphere of hydrogen, helium, and methane, which gives it its distinctive color. It's a world of extreme weather, with winds that can reach over 1,300 miles per hour, the fastest winds in the solar system. These winds whip around Neptune, creating massive storms, including the Great Dark Spot, a storm system so large that it could engulf the entire Earth. Neptune also has a faint ring system and 14 known moons. Our solar system is a marvel of diversity and wonder. From the scorching surface of Venus to the icy winds of Neptune, each planet tells a story of cosmic evolution. With ongoing research, who knows what new worlds we'll uncover next? Maybe we'll find evidence of life on a distant moon, or perhaps we'll discover a new planet lurking in the outer reaches of our solar system. If you found this journey fascinating, don't forget to like, share, and subscribe for more cosmic adventures. Until next time, keep looking up at the stars.